In this next section of notes, we're going to look at the idea of a combination and then applying that to probability. So you'll remember that we talked about permutations previously, and we said that permutation, those are where the order was important. And we did a problem with ice cream scoops. And we said, would it really be different if you had an ice cream with one scoop of vanilla, chocolate, and strawberry versus if it was strawberry, chocolate, and vanilla? Those really probably wouldn't be different, so that would actually truly be a combination rather than a permutation. So that's what we're looking at here. What if the order doesn't matter and we just care that we picked 3 flavors of ice cream? We didn't really care what order we picked them in. So rather than the P for permutation, where we did NPK as our notation last time, we've got a very similar notation with a C for combination. Now the way it relates to each other, if you don't care about the order, there's fewer possibilities. So you can see we have the NPK and we divide out K factorial. That's where we're coming up with those fewer possibilities. Again, don't worry a whole lot about the formulas necessarily. It's going to make more sense to kind of work them out by hand and also then to use your calculator. But here are the formulas if you are curious about that. Now, in terms of looking at probability, we looked at some probabilities earlier in the chapter. Remember, to find a probability, you take the number of successes divided by the number of total items in the sample space. So we're still looking at that idea, but now we're going to apply that to permutations and or combinations. So here's an example. Let's say that we were playing the lottery and we wanted to know the probability that we would win the jackpot. So here's an example where you have to pick 6 numbers, and the numbers are numbered from 1 to 49. And if you get all 6 of them right, you win the jackpot. So if we're trying to figure out what that probability is, I always like to start with the denominator first because to me that just makes more sense. So I'm trying to figure out every possible way I could pick 6 numbers out of 49. So that'd be 49, choose 6. And there's almost 14 million ways to do that. But there's only one way to win. I'd have to pick my 6 numbers out of the 6 that are winners. So there's really only one way to win. So 6 choose 6 is 1. So there's a very small probability once you divide those out on your calculator of winning the jackpot. Now, before you move on, there is going to be a separate video on how to put something like 49 choose 6 in your calculator and get this large number. So make sure you watch that video first and then go on to try the practice questions.